give you a brief introduction to myself. So my name is Robin Lester. I work for Microsoft. I work in a division of Microsoft called OCP, One Commercial Partner, where we help our partner ecosystem. I specialize in databases and machine learning technologies, and today I'm going to be showing you some of the stuff that we have in terms of machine learning technologies. We'll be talking about we'll be talking about all the kind of new things that are coming out in the industry space at the moment. So thinking about how you can understand models, how you can interpret those models, how you can understand if you have bias coming into your machine learning experiments. So we'll start off talking about that. And then we're going to move into talking about computer vision, which is quite a hot topic. So we'll be talking how you can create your own computer vision models and how you can use some of our technologies to do it. Now, 90% of the stuff that we're going to be talking about today will be open source technology. What we do at Microsoft is we invest in open source, and we in doing so we give you added add-on tools to let you use those open source technologies. So we'll be doing a lot of Python today, and I won't focus too much on our tooling. I'll talk more about the methods and stuff behind it, but I will show you a couple of things about how our technologies are helping to help you do open source. And maybe surprising to know that we are actually the biggest contributor to open source in the world, which is obviously quite a change from the earlier days of Microsoft, where we were trying to get rid of open source. Okay, so let's start. So if you are, because I work at the partner side of things, so just put this slide up here. If you're interested in becoming a Microsoft partner, just go to partner.microsoft.com. We have a very rich program for partners, and give lots and lots of support, both technical and non-technical support. So I won't go into too much detail, but if you're interested in becoming a partner, if you're developing software, or you're providing consultancy services, then it's definitely worth checking that out. Okay, and I'm not going to talk about Power BI, but I will just put this slide up here. You can do quite a lot of machine learning stuff in Power BI, and we have a workshop that you could go through, Power BI AI workshop, which shows you all the aspects of Power BI. So if you're new to data science, or if you need some toolings that let you play around with data, that's there. Like I say, we're not going to dive into that. We're going to jump straight into jump straight into talk about responsible machine learning, and we talk about bias, these kind of things. So machine learning is in a place really at the moment where the industry has moved on, the technology has moved on much faster than any legislative powers have. So lots of things are happening in the world in terms of machine learning doing things that we have to question if they're the correct things to be doing or not the correct things to be doing. So we see lots of stuff happening in terms of irresponsible ML, either by design or by not understanding the space that you're working in. We see machine learning algorithms that are only really designed for white-skinned males, Caucasian males, and they fail a lot when it starts to come to other cultures, ethnic backgrounds, females, etc. We see machine learning being used for purposes that may not necessarily be particularly ethical. So with all the new innovations that we've seen over the last few years, there's a focus on making sure that we do responsible machine learning. We make sure we do ethical machine learning. So we actually ask all of our partners to sign a pledge to say they'll do ethical machine learning, and we've offered toolings to help you do this. So we're going to be talking about some of these toolings today. So to do responsible machine learning, you have to be able to understand your model. So you have to understand what your model's doing, and you have to be able to create a fair model. For example, the demos that we're going to be going through, we're going to be talking about a loan process. If a loan process was favoring a male over a female, or white person over a black person, then it's it shouldn't be doing that. That's not a fair model. It should be working on things such as how much income you've got coming in, how your ability to repay those kind of loans. So understanding your model, understanding what your model's doing, understanding if that model's being fair by the parameters that you're setting. And the other innovations that we've been doing in the space, which we won't really cover in too much detail, is being able to protect your data, have confidential machine learning, so integrating it with Azure Active Directory and making sure your data is secure, etc., and controlling your data with audit trails and data sheets, just to understand, just to make sure that your data is in the right hands and it's not, no one has access to that data that shouldn't have access to that data. But like I say, we're going to focus on the understanding of fairness. So let's have a look at the loan decision process. If you create a loan, you want to make sure that it's a fair model. So we use Fairlearn to do that. And you want to make sure, want to understand who has been accepted and why they've been accepted. So understanding even down to that single level of, if one person's come along to get a loan, why has that person been given that loan, or why hasn't that person been given that loan? So to understand fairness, you're obviously taking the features through, and you're processing those features, and then at the end of it, you can look at the feature importance of how each individual row in your model was understood. And in that, you can understand if your models are weighted more to one particular set than another. So are loans being given to more one person or one group? So we have so we've been developing a few different toolings in this space, and these are all pretty useful if you're going to start a machine learning project. So we have harms modeling, which is a framework that you can look at to assess the potential for harm. So if you're creating a machine learning model, you want to make sure that you're not harming your organization you're working for, you're not harming the people that's dealing with, you're not harming a third party. So there's lots of ways of thinking about how you might actually be harming a group or a set of individuals. So this harms modeling will let you run through a process just to have a think about what elements of your model you might not be doing in the correct way. Obviously, most organizations, that the more trust you have in an organization, the more it's going to do business. So you want to, if you're developing models, you want to make sure that those models are going to be trustworthy, and you're not going to end up on the front of a newspaper with showing that you hadn't really thought about the ethical implications of developing a model. So we also have a process that we document called commitment jury, where this is where you have stakeholders coming in, look at your model and understand, and just getting a better idea of if your model will be causing harm or not. So there was a good example a year or two ago where a model was created, and that model believed it could identify someone's sexual preferences to about 80 to 90%. So obviously technology is there to do these kind of things, but no one wants to enter a room and a machine be making a judgment if you're straight or gay. So understanding if your model is going to invade people's privacy, understanding if there's any harm in that. So that's another technique. We have judgment call. It's actually quite a fun game. There's a picture. It's a card game you can play, and it's basically, if you have the problems that you're thinking of, you can play this game to get a good understanding of, and go through all the different connotations of where you might be causing harm, where you might be doing something non-ethical doing that. Okay, so talking about fairness in AI, talking about all the negative aspects. We talked about this, so I'll just go forward. So we have toolings in here in Azure machine learning to be able to do this fairness, and we'll demo some of these in a second. In fact, let's just jump straight into the demo here. Okay, so for the stuff I'm doing now is I'm going to be using this is open source technology really. At the end of the day, we're running Python. I'm just running it in the framework of Azure machine learning. So what, like I said before, what we do is we try and make it so you can do things much easier and more quickly using this Azure Machine Learning Studio. I won't go into too much depth of this unless I have time towards the end. Effectively, the examples I'm going to run today, I'm running on some compute. So I have a compute node in here that I've spun up, and then I'm going to be running notebooks that will be using that compute node. So for example, we'll be running a Fairlearn notebook here. I find the compute it's on. I can integrate with this with Git. So this these notebooks actually, I can just jump onto that terminal, start talking to Git, and control my experiments that way. I can, yeah, okay. I can also all of these notebooks I have here are controlled in blob storage, so I can go off and spin up on different sizes of compute that I want to. So I could have a GPU compute. I could have I've got this cheap compute because that cost me, I think that cost me about 7 cents an hour to run. So you know, you can go and have a very run this very cheaply, and obviously I can pause my compute as well. It doesn't cost me anything once I pause my compute. But for this experiment, I'm running on this one. This is a 4-core. That one's a 1-core. This one's a 4-core. Probably don't even need that much power for running these experiments, just to make it a bit quicker. And then, really briefly, we also have. So this is where I might run my notebooks from. Everything I'm doing, though, you could run locally. You don't have to run within this environment. It's just this environment makes things easier. So I used to have about 10+ different Python environments on my laptop, which started to become a pain to control, understanding which ones had which packages and which versions of packages in. And every time I want to start something new, I'd have to go in and start and spin up and do like another set of installs, pip installs, contract installs for all those environments. What we have here is when you spin up one of these computes, it's pre-installed with all the common packages. Excuse me. All the common packages. So it will have scikit-learn, it will have Pineapple, it will have NumPy, Keras, all of those different things in here, plus also extensions, so you can use Azure Machine Learning service. So what does that mean? That means that when you run experiments, your experiments can be controlled. So here's a bit of a messy, excuse me, it's a bit of a messy in here, but so these are experiments I've run previously. Let's just pick one at random. So here's an experiment, and you can see I've run multiple experiments on here. I can see this one's a classification. I can see that I have my accuracy score in here. I could go into look at the individual experiments, understand all the aspects of the metrics that those experiments are putting out. This one's support vector machine. And then I could look at explanation preview. Oh, in fact, yeah, all the stuff I'm showing here, you can run in the studio as well. I'm going to show you the code through the code. So I won't go into, I'll just cover this off really quickly before we move on. We also have compute clusters. So that's for running notebooks on. Like I say, you could run it on your own laptop if you wanted to. This is for running compute clusters. So if I want to do a training of a large model, I could go off and spin over multiple nodes. So I could run GPU nodes. That's a GPU node here. I could run on just CPU nodes. I can choose how many nodes I want things to have. So like this one has 10 nodes, but I could go up maybe to 100 nodes and run things across in parallel. We have inference clusters, which are AKS, Azure Kubernetes, or you can even go off and talk to things such as Databricks or HD Insight, which to do cluster in there. Okay, so I won't dwell too much on this. Let's jump into the actual code. So let's start off with Fairlearn. So let's say we have a model. So I'm just loading in the key components, and this data I'm using here. This is the data to understand if someone should be getting a loan or not. So it's coming from census information from the US, which is quite a nice data set. It's not too easy to do stuff to create models from, but it is possible to create models on the back of it. We usually get about 80% accuracy. So we have information like people's age, working class, education number, their marital status. So for the purpose of this, I've put these into integers rather than strings, just for the models. Occupation, relationships, the gender, the race, all the other information, and also we have another field at the end that will be, in fact, here it is, the field that will say if they should be getting a loan or not. So all those people in there don't appear to be getting a loan. Let's just actually have a down. So we do have some in there that will be eligible for a loan from our, say we're a bank, our banking system will be able to say, right, these people have a loan. Now, so in understanding people should get a loan, we might want to, if as a bank, we might want to train a model. So what the first thing we'll do is go off and think about the best kind of models to get. Now, if we were going off and wanting to train a model, there's a few things we could do. We could go through all the different types of model. We could do a lot of data science and feature engineering behind it. At this point, if I was a bank and I wanted a model, the first thing I might do is I might come into Azure and I might go off and go into automated ML. So in automated ML, we can basically create an experiment, and that experiment will go away and look at the best possible model that it can get for the problem that we're presenting. So that's our data that we're using. I'll go next here. And then it will work out what, let's create a new model. And model one. The column that we're trying to look, in our case, it's income, or how much income they get, equivalent to how much, if we're going to give them a loan. We give it a compute cluster to run on. So the compute cluster I was showing you before. Oh, sorry, no, I want to create a new one. Okay, there's a new one, and I'll set this running off in the background, and we may come back to this later. I'll just show you this process. So this is a classification process. We've recently added the ability to have deep learning in there as well. If you want deep learning, we could also do regression. We could do time series forecasting. We could do all this in code. You could run this locally on your laptop. To say, but I'm running it in this environment, and I'm using computes that's all kind of pre-set up. So these are basically going to run off on Ubuntu clusters, and that one I chose was reasonably small nodes in there. I think they're about 2 core, those ones, so it's going to be quite cheap to run it, but you could scale out as many as you want. So let's sort of look at additional settings in here. So I just want to we don't want it to run this one much, so let's run it for half an hour. Probably won't even need to take that long, so we'll let it do validation, auto validation, max and current iteration. So I know I have 20 different nodes on that. In fact, I might only have 10 on that one, so I'll run 10 in parallel. Right, the thing I'm trying to look for is accuracy on this. I've got obviously different things I could do, area under the curve, etc., the precision, etc. So we'll save that, and we'll go off and we'll finish, and we'll let that one go off. So if I was a bank and I wanted to create a model, first thing I might do is see what kind of algorithm that I want to use to create that model with is going to give me the best in terms of the highest accuracy. So the thing I'm looking for at the moment is really the highest accuracy in the classification problem. Either a 2-class classification, really, they get a loan, they don't get a loan. So that's going to run off, and we'll come back to that later. So let's say that I've gone through all that, and I've thought about the kind of algorithm I'm using. So now I want to go away and understand a bit more about my model. So there are a few things I could do. There's my data set. Sorry. Okay, so I'm going to split. Okay, so first thing I'm going to do here is, because I'm a bank and I want to give people loans based on merit, not the sex or the race. The first thing I'm going to do is I'm going to drop these 2 columns from my data set. So I'm dropping sex and race, so they no longer feature in my data set. So you might say, now, is my model going to be fair? Well, maybe, but not necessarily, because we might find that the other features we have in our data set actually may still mean our model is going to be less fair in being able to, it still might be favoring people of a particular gender or a particular race. So we've removed them, and we're just converting our Y value into true or false, our label that we're trying to predict. So we'll go off and train a model. So we go off and we're using a decision tree classifier here. We go off and train the model, and what we get at the end of that is we get 97% accuracy, which is quite nice, quite high. And then we can just look at our confusion matrix here to see how many we're getting correct. So so these two here will show us how many we're getting correct in each two sections. So they shouldn't have a loan, or they should have a loan. So we're giving a few loans to people that shouldn't have a loan, and we're not giving some loans to people that should have a loan, but we're still 97% accuracy. So then we put the sex column back in there just so we can look at the differences, and we see in here that we have more males that have been giving a loan than females. So we can then break this down and say, well, let's also understand our model in terms of so remember we trained it without male or female in it, but now we've added it back in. We can see how that impacts on the model. So we can go in and we can see how accurate is the model for male, and how much accurate is the model for female. So we're actually 99% accuracy for female, but only 96% accuracy for male. So there is some gender bias that's happening in there. And we can see how often people will be given a loan. So we can see that males are being given a loan 27% of the time, while females are only being given a loan 10% of the time. So at this point, we can use our Fairlearn dashboard. So we just import the Fairlearn widget, and we can run this off. And here we have the Fairlearn dashboard, which gives us, rather than running through lines of code, etc., gives us a much nicer and easier way of looking at the information. So let's just get started. So in this one, the only metric I've put in here is the sex for this one. So as you can see, the sensitive feature name. So the feature I'm interested in is the sex. And that's my model information. So pretty simple to set up. And then I can look at my model based on things like the precision, the recall, the balanced accuracy, or the accuracy. We'll just keep it simple and use accuracy. And so now we can see this a bit better and a bit more graphically. So we can see the males accuracy of the model for males 96 and females 99. And we can see that males are being given a loan more often than females. Now we're a bank. This might be a problem. If someone says, "Why didn't I get a loan?" We might say, well, hold on. Yeah, so we go through an audit and we've shown that we're giving men more loans than females. It might be a problem. This is just to briefly jump back. We can do, I'm doing this as a two-class classification. We can do this regression. This is just showing you a regression algorithm. We're trying to predict the person's age from that data. As you can see, we're not actually very good at predicting the age, so our accuracy isn't great. But so that should be a line like that, really, where it's all over the place. So we weren't really good at predicting someone's age from this data, but we can still do the same things, just showing you can do it with regression as well. So we mean squared error, or there are squared score, the two more common ones. So we can do that breakdown with a regression algorithm. I'm not going to go into too much detail on this, just want to show you this is also possible to do it across different algorithms. Okay, so we can add the person's race as well. So we at the person's race, we can break that information down again, but let's look at it graphically on the dashboard. So look at someone's race, and we'll be looking at accuracy, and we can see that the accuracy is much higher. It's not so high for white, but it's much higher for other races. And if we display the how often people are getting loans, so Asian Pacific Islander much more likely to get a loan than the first one is the other class. So yeah, so again, there is some differences in how we are allocating loans, and are these differences being based on the fact that that people's gender or race is being thought about. So if we wanted to if we wanted to then think maybe we need to create a new model, we need to create a new model that's going to give us a much fairer, less biased model in terms of people's gender. So what we can do here is, rather than having to go around doing lots of feature engineering, messing around with different algorithms, this kind of stuff, we can go in and we can ask Fairlearn to do it. So what we're doing here is we're saying, Fairlearn, we want to create a mitigator. So give us a model that's going to be much more fairer to, in this case, we are looking at fitting on someone's gender. Do we run that? I've run these all beforehand. Some of these, this one takes about 1 minute to run. So, but all of these are pretty quick in terms of how quickly run. It's just didn't want to have to sit here for a minute waiting for that to run. Okay, so we run this. This will go off and create a new model, and then we can look at how our model's been doing. So accuracy. So we can see our initial model and our new model. So our new model is a bit less accurate than our original model, but it's got a much lower disparity in prediction. So this was about 18% disparity. This is 2%. So we can go in and we remember what this one looked like. Let's look at our new model, our mitigated model. And when we look at our mitigated model, we can see there is a bit of difference in the accuracy, but in terms of people getting a loan, we see that it's much more even. So 26% and 24% male to female. So this model's made it a bit more fairer, taking less into account the gender. So we can go off, create a few more models. So again, tell Fairlearn to go off, create some models. And so what we're doing here is we're basically doing a few different models. We're doing a logistic regression using a decision tree. And then at the end of it, we come through and we can look at how all those different models did. So as you can see, there's the mitigated model, exponential gradient, is that one, and then the other ones that we created, deep neural network, logistic regression, the first model. So it does turn out that the model that Fairlearn went off and created is actually going to be the better model for having less bias. So I just paused there. Okay, so just looking at questions. What is the simplest way to get started with AI if one doesn't know how to code? Okay, so the simplest way to get started in AI is we have in here a designer. And this designer, in fact, let's do one I did earlier. This designer is basically drag and drop. Oh, sorry, I've overcomplicated it. Let's take a few things out of here. So this designer is basically a drag and drop interface. So I can go in here and bring in data sets on the left. And this gives you the ability to get started, understand the kind of core concepts of machine learning without having to drop in and start writing Python or R. So that's, in fact, this is a good example because it's the same data set that we had before. So this is the adult census income again, income or loan. I kind of use that term interchangeably for this data set, but all of that information in there. And we can see all the kind of the histogram and the breakdown of that information. Let's see if I can slide that back a bit. So we go in, and with any machine learning problem, you'd want to split the data into two. So we split the data here, results in two different data sets coming out. So I've told it I want 80% split down one side and 20% split down the other side. Now, ignore this stuff over here. That's overcomplicating it a bit. So we have our split data coming down here. We train a model, and the type of model that we want to train is a two-class. It's a two-class problem. If they get a loan, don't get a loan. So we chose a two-class boosted decision tree. Train the model, and then we'll actually get, at that point, we've trained a model that actually can go and take that model. It was basically a pickle file. So we could, if we wanted to, not stop using the machine, the visual interface, and take that model and go off and do some stuff in Python with it. So we can register that model up there, and we have a registry to store for all the different models in Azure Machine Learning. But like I said, you could just go in and you could just download it and put it on your laptop and use that there. So where's my logs? Actually, it's because yeah. So under here, you would register that model, then you can download it from there. So that's our trained model. So we split the data 80%, 20%. So 20%, that's the 20% run of data. That 20% will go into score the model. So we can score the model, see how our predictions have happened. So that's the thing we're trying to predict. That's our scored label. So see how good it is, and it looks pretty good so far. That's the probability that someone is going to be over 50k. So actually the first one I got wrong, but it's getting quite a few of them right. So if we really wanted to understand how well it was doing, we can click onto, we could put an evaluate in here, and we could visualize those results. So we can see the ROC curve here. So to have a perfect model, we would have a L going up that way. If to have a model where we were just flipping a coin as to what the answer was, so we would have a line going this way. So we can see that we have got quite a good model that's come in. We can see the confusion matrix, so we can see we're getting the predictions quite well, and we can see the accuracy of our model is 87%. So if you want to get started in machine learning, this is the great way to do it. Just come in here, use the drag and drop interfaces, understand the key concepts. When you're ready to, and you can also take this and you could publish this. So I could then publish this as a web service. So people could throw data at it, and it would then give them predictions. So I've basically created a machine learning model from some data and published it, and I have it as a web service, and I haven't had to write any code. Yeah, so that's great way to get started. Also, a great way to do more. Even if you are good with code, if you know Python or you know R, sometimes it's quite nice and easy just to run the code through here, and takes you a little bit shorter amount of time to do it, and you can just play around with some stuff and until you're ready to jump into the code. Like I say, everything that runs in here, you can take all of the outputs of this, as you can see here, or these are all the model statistics that we had in there, all the stuff from our score model, etc. Okay, so hopefully that's answered that question. So another question: learning advice to get started. So yeah, talked about that. We have lots of learning as with Microsoft. You just go to Microsoft and web browser, and there's quite a lot of stuff that we have available. Okay, so any help on NLP side? So natural language processing, yes, we have quite a lot of stuff in GitHub. Let me show you this before we move on as well. So within our notebooks, so you spin up a machine learning workspace. This doesn't cost you anything. If you're not running any compute, it's just sitting there. It costs you a few pence a month for just the storage costs behind it, but it doesn't really cost you anything, only when you start doing stuff with compute. But under here in Git, we have lots of examples and tutorials. We've got quite a few ones on using natural language processing and BERT, under how to, and then I can't remember exactly where it is, but under here somewhere we can use, in fact, if I do a search, NLP, and this one potentially, that's doing image classification. We do have some in there to do with natural language process. You can go in and look at them. In fact, most scenarios have there. So PyTorch examples, Kira's examples, etc., etc., etc. So it's a good starting place if we want to go down to coding. Okay, let's before we do any more questions, let's quickly jump on to the other aspects of the talk that I wanted to talk about. So this is model explainability. So we talked about fairness, but now we might want to understand our model in a bit more depth. So there's two different types of, in fact, let's just jump to some slides just to progress my slide deck on. Okay, so right, done that. Okay, so interpretability is actually taking your model, opening it up so you can see what's happening in your model. Now, there's there's two ways of doing this. You can do black box models, you can do glass box models. So glass box models are models that have been designed to be interpretable, so very easy to use. But you can also use black box models. So black box models effectively can take any model and then it will look at the inputs, look at the outputs, and then it will work out how it's gone and worked out which features are the most important for on a global and on a line by line scale to work out which features per line are the most important features. So I'll show you some glassbox models and some black box models in a minute. So mostly using SHAP. So SHAP stands for Shapely Additive Explanation. How this works is in a very simplistic way. I'm not going to go too deep into the data science, but in a very simplistic way, what it will do is it will work out the feature importance of the whole model. So we have these labels we're trying to predict. We know the feature importance for each of them. So in this case, feature importance of x1 is 2 times, the feature importance of x2 is 3 times. So these are our features that we're using to predict this. So we can then say times them by, so x1 times by 2 and x2 times by 3, and that will give us how important these different features were used to understand the model on a line-by-line level. So I'm not going to go into too much detail on that. Just to show you some of the maths behind how we predict it. So like this. Okay, so using the same data set, we can use a glass box. So this is interpret.glassbox. So this is a model that's been designed specifically to understand it. A model that's been designed specifically to have explainability behind it. So we can run our data through that. And why didn't that show anything? Again. So we should have had a graph at the end of that. For some reason it didn't display. While we're waiting for that though, let's go down and look at some black box. Probably most of the time you're going to have created a model somewhere else, so you want to use black box classification. Black box interpretability. So this I'm doing classification. You can do regression, you can do regression as well, etc. Okay, so I've taken my data, I've run the predictions on it, I got 80% accuracy. I was just using a decision tree classifier here. As you can see, the decision tree there. So the confusion matrix rather, it's reasonable, it's 80%, it's okay. So I tell it the classes that I want. So if we're giving someone alone or not alone, still the same data set that we're using before. And we run through a Tableau Explainer. So this Tableau Explainer, what it will do is it will identify what type of model it is, and it will then run through and create an explanation for that, all the different lines of the model, etc. So we run that through that. That takes took 1 minute to run, and then we will look at the global explanations. So we can see all the different all the different features and how it's weighted them in understanding, in creating this model. So it actually makes it look a bit nicer. So we can see relationships quite high in terms of that model. We can see sex and race in there. Ideally, we'd want them to be 0 if we're working out if someone's going to get a loan or not. But one of the nice features of this is that we get this dashboard. So you can pop this dashboard out. I just opened in a new tab. Here's this dashboard in a new tab. So if we look down here, this is our global importance. So our global importance, I have age in buckets here, and number of data points here, but I'm seeing determined on people's age how likely they are to get a loan. So 17 to 31-year-olds, they will not likely to get a loan, and not likely to not get, and no loan is quite low. So we can see as the age goes up, we're more actually in this data set. It's interesting that we more like to give people a loan. Maybe we don't want to. Maybe if we stick that as categorical, we'll see it broken down by every single age as well. So, say we can play around with this data and understand this data. So in terms of this data, is statistically you're less likely to get a loan if you're 45, 46, 47. We can see a kind of pattern coming in there. Let's go to our data explorer. So a data explorer, so we can split this down by, we can split it down by age and see, we can split it down by age, and then this is the chance of having a loan or not a loan. We probably, if we want to see fairness in this model, we might want to split down by race, so we can see race, different races, and chance of getting a loan or not a loan. So we can see that 0, only one person would have got a loan out of that. Wouldn't have got a loan out of that. This number 3, we can see that nobody would have got a loan, everyone would have got a loan. So this gives us a bit of ammunition to start thinking about our model, start thinking about the features, and do a bit more investigations into what's happening. So we can go into look at our feature importance. So this is our global feature importance. So this model thought relationship was the most important thing in understanding someone gets a loan. If we go down here, we can see the feature importance drops off until we get to things like person's gender and then race. So both quite low, but but them impacting at all, is that acceptable? We can look at different ones of these, different relationships that have come out, the education number, the age, all the different data points, the chance of getting a loan for that, a couple of gains. So if we then slid across to something such as their gender, we could then look at, sorry, I'm on the wrong one. We could then look at the different feature points. So this is someone's race against their probability of getting a loan, so getting a loan, not getting a loan. And we can click on these individual data sets in here, and we can see how these individual data points have predicted that. So let's just pick a couple. Let's pick 3 at random so we can see them together. And then we can go across and understand, so these 3 data points, 757, 2134, and 467, we can see the, for example, this one, race was involved in the decision if they were getting a loan or not for that data point. So we maybe want to look at the data point and understand why, what's happening with it. But still the highest ones are relationship, work class. So, it's not the most unfair model, but but as you saw before, when we're going through the Fairlearn, there is still some unfairness around it. Okay, so we can also visualize this in different ways, etc. And then if we wanted to understand using the local explanations, so kind of going row by row, we could go off and we could look at everyone's, from the data frame, everyone who has so everyone that is most, that where their gender is the primary contributor to the decision for them to get a loan. So what we're doing here is we're looking at all the rows where, so this one here is where we're looking at all the rows of people who where that was a key influencer in them getting a loan, and again all the ones here where race was a key influencer in them getting a loan. So again, we might want to revisit these. Maybe if we've been using this model, we might actually want to revisit if we've gone out and refused someone a loan or given them a loan, and it appears the model was doing that based on their race. We might want to say, well, actually we need to change our model and we need to talk to those people that we either refused or accepted a loan on. Okay, so let's take a pause for questions before we move on. So you know you have a model and you know its accuracy. How can you use the model practically and see specific predictions? Okay, so I've shown you with that how to show specific lines in that model, so interpreting it. Okay, right. Okay, so let's let's move on briefly. I did say we would cover some. I did say we would cover a few elements of vision, so let's do that really quickly. We have different ways of doing it. So I'll show you custom vision. This is our custom vision suite. It's part of cognitive services. You can go into this and you can create deep neural networks for just through drag and drop. Again, so the question for how do you get started in machine learning if you don't want to do any coding or you don't have the ability to coding, we have cognitive services, which gives you elements to add on to your that lets you use them to add to whatever it is you're developing. So if you have an application you're developing, you might start looking at some of these cognitive services. We've got things like anomaly detector. We've got things such as voice to text, translations, ability to write bots. We've got the ability to do speech to text, speech recognition, face recognition, able to read text from images. This would take an hour or two to go through all the different ones. Just make you aware that we have cognitive services that let you do a lot of machine learning problems. We're talking more of in this one, this is a cognitive service, but this is custom vision. It lets you understand. You can give it your own. It's transference learning basically. So we've trained a deep neural network, and then you can add create images, and those images can then go in. You can then use those images to create your own domain of things that you want to predict. So as you can see, I was giving it some pictures of some fruit, bananas, apples, pears, etc. I can look at the performance of this model. So all I did was upload those images. These are my training images. I've uploaded them. I can see that it thinks it's pretty accurate in, you see the precision recall. It's pretty accurate in identifying them. I'm showing you this is a image classification, but you can do this with object detection as well. So in here's one I ran in earlier that it's never seen before. So it predicted this as an apple. One of the benefits that we have here is we can go in and we can export this model. We can export it in a few different flavors, but Onyx is the one I'm going to use. So Online Neural Network Exchange, which is a project we've been working with Facebook on for a few years now, basically just making ability to have models that will run in any environment. So it's a standard for models. So I've run that, I've downloaded it, and I could take that and I can put it into which one should we do? Let's do this one. I can put it into is this going to work actually when I'm showing my camera? We'll see. It might not like the fact I'm showing my camera. No, it doesn't like the fact because it can't. Okay, I'll tell you what, I'm going to turn my camera off on the presentation. I'll turn it back on once I've okay, so turn the camera off on the presentation just so we don't have any sharing issues. My webcam should really have two. Okay, so we might have a problem. Let's just try that once more, and if that still doesn't work, I'll show you a different one. No, okay, I'll show you a different one. Hold on 1 second. I've just stopped sharing the screen, haven't I? There we go. Right, we should be shared again. Right, okay, good. Let me just try a different one then, because it doesn't like the fact I'm sharing my camera on another one. Let's try this one, and I'll explain what this is if it works. Otherwise, we might not be able to do it. Is it going to run? No, it doesn't. Okay, right. So unfortunately, okay, we'll talk about it. So unfortunately, I can't show them because my the software you're using to do the presentation has got control of the webcam. So I can't show you anything with the webcam, but that's fine. I'll tell you some. I'll show you. So what you'd have got there is some real-time images, and I could have put objects in front of it, and it would detect the different types of fruit or a mobile phone or this kind of stuff. So I'll just go back here and we'll look at some other projects that I've got. So that was this is quite an interesting one. It's circuit boards. This was a real use case where a customer had to have identify they're printing circuit boards, identifying circuit boards for good or bad. When someone's looking at circuit boards, it only takes a couple of hours for them to stop being very efficient at identifying if a circuit board is a good circuit board or bad. As you can see here, this is a bad circuit board, it has a break in it. But we can use this to basically train a model that will identify good or bad circuit boards, download that as an Onyx file, stick that on a device, it's even as simple as something like a Raspberry Pi, put that in the factory, and then that can just sit over looking at circuit boards, identifying any breaks or problems with those circuit boards. And that's all done in a codeless environment. So at Microsoft, we've been trying to democratize AI. So we've been trying to give you ability to write machine learning code to use artificial intelligence without having to drop down into different into Python or R. This is another example. This is a example where we're doing a object detection, so understanding where different things are in the object. So this one, we started identifying guns. This is obviously a really bad one to demo in real life because don't want to obviously brandish a gun in a presentation, but as you can see, it's identifying things that are interesting for me in the picture. So it's identified that there's something there, there's something there, but for this example, identifying different guns. And then again, I can download this model. I can use this to identify images, objects in a picture. So that's using custom vision. The other two ways of doing cognitive services custom vision. The other two ways of doing identifying objects in images are you can create your own deep neural network, or you can use CV2. So this is a Python library, all open source. I'm just using machine learning, Azure machine learning to run it because it's much easier to do it this way. So in this example, I'll just show you some of the, so it's using what we call cascades. So you can download cascades and they will identify different elements of a picture. So we can take this image. This is a picture of 6 people. So if we're going to do some object detection in it, we might turn that to grayscale. So we grayscale the image. We use the cascade. So I've already downloaded a cascade that will identify someone's face front on. You can download multiple cascades. You can create your own. Effectively, there are lots of embedded XML that identifying the different kind of things that are interesting to be able to classify a person's face. So has it got a nose in it? Those kind of stuff in a very simplistic way. So to take the faces, identify the faces, we found 6 faces. Well, let's see those faces. So as you can see, it's identified them. Really quick. Obviously, because it's so quick, you can run this in real time. I do have an example of running this in real time. Obviously, it won't work when I've got my running this the web conference software. We can also use Cascade to detect eyes. So this one, go off, have a look, find people's eyes. We didn't do too well on him, but we got everyone else's eyes. This is quite an interesting one. So we take a picture of someone without any real eyes, just lots of eyes painted on a face. Can our Cascade do that? Not really. It thinks the mouth is an eye because it's looking for particular things, and we can tell that those aren't really eyes. So it wasn't that good. We'd probably, if we were using a deep neural network, we could start training it to identify those as eyes if we wanted to do so, or to not identify those as eyes. We could actually probably also do this in our custom vision as well, and train it with all these different eye pictures. Let's take that picture of lots of different eyes, and we can see that's pretty good. Again, the way the Cascade works is it's looking for different elements, and then it's giving an accuracy or how confident it is. Not too some of these it's messed up, but most of them it's getting right. But this is I always think of this as a cheap and nasty way of doing object detection. It's very easy, very quick. As you can see, I'm only running a couple of lines of code. And we can pull out all the different people's eyes, and then we can also do this. This is identity. So let's say we had this picture and we wanted to remove the background, as in the kind of might see in a kind of green screen kind of thing, but this is a bit slightly more complicated process. So what we do is we take the picture, we look at the hue and the saturation of the picture, again just using OpenCV, so we can see all those three elements of it. We look at we've reversed the filter, so we can then just get the background, so we can see the background. We then view to then identify just the skin, so we can then see, so between this one of just the background and just this one, we can then start to just identify just the skin from the both of them. And as you can see there, we've now just identified the people's skin, and so we got rid of everything else apart from the people. Obviously, teeth aren't skin, and there's a few. She's got a shine on her head. Obviously, there's doing that. So then we just go down to one. It's near Halloween, so it's a bit like a Halloween picture. So it's just identifying the skin. So just showing you a way of taking an image and bringing out aspects of that image. Very simple. You can do object detection. You can do identification. This is just using CV2. If you wanted to go deeper in, you'd probably want to jump into you're doing a deep neural network or custom vision, which is just transference learning. So we've already done all the hard work for you, just dragging your images in and using them. Right, I am at time, so let's just jump to any questions. Okay, so clicking explain a bit more about dangers of overfitting. Okay, so yeah, so overfitting is where you have a model, and when you've trained that model, it's only really good at identifying the information that you've used to train it. So you can get if you've got a small data set that you're doing the training with, you might end up with overfitting because it hasn't got enough data points in there to understand the complexities of it. Also, certain algorithms will be more prone to overfitting. So if you're doing, I was a classic example is if you're doing a forecast or a regression and use a decision tree to do that, that can sometimes lead to overfitting. Now, how do you get around overfitting? Use more data, obviously, but the key way is really to do cross validations on that data. So you take the data and you take some data, reserve some data for testing, and so let's say you have on your records, you take the first 10% and don't train the model with that. Let the rest of that 90% train the model. Then use the 10% to see how good that model is. Then do it for the next 10%. Then do it for the next 10%, and just run through all of the elements of the model to then see how good it is at predicting all those different aspects of it. So that will help you avoid overfitting. You still might be in a position where you are getting some data overfitted. So like I say, always more data is better to try and avoid any kind of overfitting.